So far, we've learned Sohcahtoa. And that Sohcahtoa stands for that you know sine of an angle is always the opposite side divided by hypotenuse. Cos of an angle is always the adjacent side divided by the hypotenuse. And tan of an angle is always the opposite side divided by the adjacent side. So Sohcahtoa is just an easy way for us to remember three definitions quickly. Now, the majority of the questions that you solve in trigonometry are one of two types. Okay? Type 1 is you solve for a side. And type 2 is you solve for an angle. If you're solving for a side, and again, the only way that Sohcahtoa works is if you have a right angle triangle. You would be given an angle, let's say this is 20 degrees, and one of the sides is listed for you to find, and you're told another side. So we've got 20 degrees, 17, and you want to find x. Well, the x, and you can always label your hypotenuse, is opposite of your 90 degrees. So hypotenuse is always opposite your 90 degrees. And your adjacent and opposite change depending which angle you're talking about. So first of all, you could, if you wanted to, we don't need to, you could find out this other angle is 70 degrees because they add up to 180. Now, if I use the 20 degrees, can you see that the 17 is the opposite side? If I use the 70 degrees, then the 17 is the adjacent side. So we have to be aware of which angle we're thinking about for opposites and adjacents. I can now use my definition to say, well, the only one that uses opposite and hypotenuse is sine. So I write sine of 20 degrees equals the opposite side over the hypotenuse. I want to then solve for x. Wow. Let's try that again. So I would multiply both sides by x. Then that would get x times sine of 20. So if I want to get x by itself, I'd have to divide both sides by sine of 20. I could type this into my calculator and get the answer. So I'll just do that with this calculator because the one on the computer would probably take forever. You get 49.7 degrees. Now, an example of solving for an angle. So now I don't know an angle, but I'm told two sides. So let's say I'm told this side is 8 and this side is 12. Again, I can label that I know this is going to be my hypotenuse over here. But that's not a side that I know. So as far as my definitions go, well, this is the angle. I know the opposite side. I know the adjacent side. So setting it up, I could write the definition for tan. Tan of the angle is opposite over adjacent. Then solving for angles, now we want to get the angle all by itself. But there's a tan in front. What gets rid of the tan? The tan inverse. So then I would have and I would type this into my calculator. Tan inverse of 12 divided by 8, and I get 56.3 degrees. These are the two main questions. Sometimes in your review, they give you parts of the question even easier. Like some of the questions would say, here's the triangle. Can you tell me what tan theta is? This is it. Tan theta equals 12 over 8. You would be done. It's not solving for the angle. It's not solving for a side. It's just asking you for a part of it. Okay? Sometimes in the review, they don't draw the triangle. They just start you here. That was one of the quiz questions. It told you tan of theta equals 1.3, or tan of b, I think it was. If you needed to solve for b, all you had to do is one step. Do the tan inverse, and you would have been done, because it was a solving an angle question. So when you're thinking about trig, you've got these two major kind of questions you're solving, either solving for sides or solving for angles. If it's not solving for a side or an angle, it's usually an easier question that's just a part of this. Like, could you tell me what the hypotenuse was? Oh yeah, a squared plus b squared equals c squared. So sometimes they're easier questions using stuff you've learned from the past. Now, we have 2 questions left in our notes. Another double triangle question. And I'm going to put an X here from C to D because that's what they ask us to find. Can you see that that is part of a right angle triangle? If we look at the right angle triangle that it's part of, it's part of the green right angle triangle. Do we have enough information in that green right angle triangle to solve for X? No. So in these questions with more than one triangle, you look, can I see another right angle triangle? Yes. I have another right angle triangle here in purple. Do I have information in that one that I could solve for everything? Yes. As soon as you have one side and one angle, or 2 sides, you can solve for everything. Okay? You need to have at least one side, though. It's not good enough just to have all the angles. So I can solve for everything in this triangle, but there's going to be one side that's going to help me with the green one. So the hypotenuse here, this is the one that's shared with both the hypotenuse of the purple one. Is it also the hypotenuse of the green one? Yes. That doesn't always happen. That's why I labeled the hypotenuse in different colors there. It is the hypotenuse of the purple one and also the hypotenuse of the green one. So I'm going to call that y, because we've already used x for what we wanted to solve for in the end. So I'm going to take out my purple pen because I'm solving on my purple triangle. I want to find the hypotenuse. I've got 47 degrees here. Thinking about Sohcahtoa, which one are we going to use? We're going to use so because we have the opposite and we want to find the hypotenuse. So we write out the definition of so. Sine of 47 degrees is the opposite side divided by the hypotenuse, which is y. Multiply both sides by y and then divide both sides. Here, I'll go back to purple. Because y is on the bottom, that's what we want to get by itself, but since it's on the bottom, we have to move it out of the bottom to begin with. Question? Okay. It's all good. So now, we multiply both sides by y. That would simplify our y's. And then we can divide both sides by sine of 47 to get y by itself. So I go to my calculator, 4.2 divided by sine of 47, and I get 5.74. Dot, 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 because I'm going to keep all of those decimal places as I work all the way through. I can now go to my green triangle and solve for x. I'll take it right here. Yeah, new seating plan. So now I know the hypotenuse. Now I look at the green triangle. And in the green triangle, here's my angle. Can you see that x is the adjacent side in my green triangle? And I know the hypotenuse now, so I would use cos. And cos of 26 degrees is the adjacent side, which is what I don't know, x, divided by my hypotenuse, which was 5.74 dot, dot, dot. I can get x by itself by multiplying both sides by the 5.744 cos 26 degrees. Type that into my calculator, keeping all of my decimal places as I go. And x is 5.16. Was there units? Their units were centimeters. Does it say, oh, to the nearest tenth? So I'll take an extra step to round it correctly. So check your rounding, check your units at the end. And finally, our most complicated question that we will get. Trig questions that are in 3 dimensions, which is just like your flagpole question and just like your building, that's probably realistic for us. We're always living in 3 dimensions, so we should be able to solve questions in 3 dimensions. But sometimes drawing the diagrams is a little bit difficult and gets a little bit crazy. So, a tower is 35 meters tall. From a point due east of the tower, Tanis measures an angle of elevation of 70 degrees to the top of the tower. Can you see that in the diagram? Can you see that this would be a 90 degree right here? Because it's going from the ground straight up to the tower. Usually, sometimes not. North, east, south. Never eat soggy wieners. Okay? So there's east, measures the top of a tower. Leaf is due south. So this is also going to be 90 degrees. You see when you draw it that way, it would be like that. His angle of elevation is 50 degrees. The question is, how far apart are Leaf and Tanis? There are names. So from here to here is what we want to solve. Because Tanis is here at east and Leaf is here at south, does it make sense that the angle between them there would be 90 degrees? I could draw that on my, put a box right there. That triangle is 90 degrees as well. Can you see that we have 3 right-angle triangles? I'm going to color code them. I'm going to color code Tanis's triangle with the tower in green. I'm going to color code Leaf's triangle with the tower in purple. And I'm going to color code the triangle that includes Leaf and Tanis and the ground in blue. 3 right-angle triangles. The X is in which color? The blue one. Look at the blue one. Can you see you know nothing whatsoever on the blue triangle? Okay? Sometimes in a 3-dimensional one, okay? Sometimes in a 3-dimensional one, it's nice to draw the triangles separate so that you can see what's going on. So here, the purple triangle, nice right-angle triangle. Label what you know. You know this is 50 degrees, and you know the height of the tower is 35. Our green triangle, I know that this is 70 degrees, and this is 35. And my blue triangle, which I'm going to draw like that. I know nothing, but this is Leaf here, Tanis here, This is Tanis at this point. And can you see that those are your three triangles separated? And we want to find this. Oops. That's my x. So I need to find information on the blue one. Can you see, though, from the purple one and the green one, we could solve everything. We have enough information to solve everything. But something is going to be more useful to help us. So what I'm going to do on my purple triangle is I'm noticing that the purple and the blue share a side. Do you see that on the big diagram? So I'm going to just add underneath this purple line some blue, because that's the side that they share, right? And same thing on my green one. I'm going to add some blue just on the bottom there. Could I find those sides? Yes. What should I call them? What letters do you want to use? We've got an X already. A Y here and a Z here. Perfect. I'll take your quiz. New seating plan.
One question I don't know yet. That's what I was going to ask.
So let's go to purple. We can find Y first. Would you use sine, cos, or tan? All right, this, we can label the hypotenuse. We don't know the hypotenuse, so we're going to have to use tan, because the definition for tan is the opposite over the adjacent, multiply, again, this is what we want to get by itself, but it's in our denominator, so we're going to multiply both sides by y to get it out of the denominator, and then we can get y by itself by dividing both sides by tan of 50. Oh, I'd really like to use my calculator here. So I've got 35 divided by, oh, this is why I didn't want to use my calculator here, because this is like frozen. But I wanted to show you something on the calculator. No, you didn't get everyone wrong. Okay, I was going to use this calculator, but obviously it's not responding right now. So I can go 35 divided by tan of 50. And the reason I wanted to do my calculator is because I'm actually going to take this number that I got, 29.36, and I was going to store it. 29.36 dot, 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 and I'm going to store it as the letter y, because that's what I used. So I go store as letter y to remember it. Some of you won't have the store button, so then you just have to have more decimal places remembered. Now I'm going to go to my green triangle. And just like my purple triangle, it's going to be tan opposite 35 over z. Sometimes z is not a good letter to use because you start to think it looks like a 2. So you just have to be careful. Okay, I can multiply both sides by z because it's on the bottom. I can get z by itself, then by dividing both sides by tan of 70. 35 divided by tan of 70, 12.73, dot, dot, dot. And this one I'm going to store as the letter Z. So now those two sides I can now label on my blue triangle because I know this one is 12.73, dot, 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 and this one is 29.36. No, you can't use it's a good question. Can you ever use the 90 in Sohcahtoa? No. The Sohcahtoa only works with one of the other angles, but you need the 90 as what in the triangle in order for it to work. You don't. You have to, if you can't store it, then you just have to remember more decimal places and type them all in. 5 or 6 is like going to be. Usually, if it says round to the nearest hundredth, I would keep 2 extra decimal places for all my work until my final answer. Then it most likely will not be. But if you round to the hundredth early and keep working, then your final answer might be off. So a couple more decimal places than what they asked for. I'll tell you about that after. So now we can do a squared plus b squared equals c squared. In other words, you can do that y squared plus z squared would equal the x squared. Plug in the numbers for y. This is 29.36 dot, dot, dot squared plus, and again, so does this question say how many decimal places they want? No. So if I want to go to 2 decimal places and I don't have a store button, I might keep 4 or 5, a couple extra than what I want as my final answer. Then your rounding will most likely be correct at the end. But since I've stored it in my calculator, I can go x squared plus, sorry, not x squared, y squared plus z squared, and I get 1,024 is equal to x squared, and then I can square root that answer. What are our units? So Leaf and Tanis are 32 meters apart. Thank you.